You're in your galactic space cruiser on your way to Outpost 52, delivering supplies for the small colony there, when alarms begin going off. You scan your displays, but something catches your eye before you can work out what's happening. You don't need a view screen, as the front section of your ship is transparent, like a one-way mirror. A colossal orange and purple cloud is sweeping towards you. There's no time to analyze it. You put the ship into a dive, as steep as it will go. The alarms go crazy, but you're too focused on getting out of danger. The ship rattles, and you think it will break up, but your ship is fast and powerful, and somehow you manage to get underneath it. You look up and see the gigantic plasma cloud go soaring past. Curiosity has bitten you, and you decide to follow it. You program your computer to analyze it. Soon the information is coming back, and you can't believe what it's telling you. This plasma cloud is a wrecker of galaxies. It and others like it have been ending galaxies before their time. You recall your studies back on Earth when you were just a young pilot. There have been studies as far back as the 21st century as to why galaxies were mysteriously ceasing the formation of new stars, causing them to end ultimately. Stars form from thick clouds of gas that have become extremely cold. They condense and, over time, collapse into solid compact matter. There's a famous photograph taken by the Hubble Space Telescope. Most people have seen it. It's called the Pillars of Creation. It's the Eagle Nebula, where stars are forming. They call these environments star nurseries. It's a pretty cute concept if you think about it. But there's a bad guy lurking, and you're following it. It's a vast star wrecker. The wrecker rushes in and sweeps the gas out of these star-forming galaxies at an accelerated rate, preventing stars from forming in the first place. It's like a giant broom. But rather than cleaning up, it's ceasing up, bringing new galaxies to a premature end. Now that you know how dangerous it is, it's best to hang back a bit. Let's see if we can see it in action from a safe distance. It had been a long-standing mystery why some galaxies don't birth new stars. The star wrecker is smart. It hangs around large galaxy clusters. There's one in particular, the Virgo cluster. This is the one that scientists studied and came across the star wrecker. The nearby Virgo cluster is 7 million light-years across and contains thousands of galaxies. When I say nearby, it's about 65 million light-years from us. Not exactly a weekend space cruise away, but it's pretty close in galactic terms. The cluster hurtles through the superheated plasma at speeds of up to 1,000,000 miles per hour. The cluster forms the basis for the large Virgo supercluster, of which the local group, where our Milky Way resides, is a member. Its proximity to us makes it easier for scientists to study. It's also one of the most extreme regions of the universe that we know of. Currently, who knows what else is out there? The Virgo cluster is also unusual, as it's still forming new stars, and we can observe them, such as in the famous Hubble nursery photo. A galaxy in this cluster is called the Messier 87. It was discovered way back in 1781 by a French astronomer named Charles Messier. It looked a bit fuzzy to him, so he called it a nebula without stars. More information on what it was couldn't be ascertained until the 1920s. Messier was well respected and in his lifetime discovered 13 comets. He was born in rural France, the 10th of 12 children. When he was 14, he witnessed a tremendous six-tailed comet in 1744. It was astonishing and was visible to the naked eye for several months. Its effects were dramatic and unusual. It was so bright that it's been recorded as the 6th brightest in history. 4 years later, young Charles saw a solar eclipse from his hometown on the 25th of July, 1748. He knew then that he wanted to explore the world of astronomy. It was meant to be. A lunar crater and an asteroid have been named after him. Nothing is mighty, however, like the Messier 87, or M87. It's a supergiant elliptical galaxy with trillions of stars. It's the second brightest galaxy within the northern Virgo cluster, making it popular amongst astronomers and amateur enthusiasts. Elliptical galaxies are older, low-mass stars with minimal star formation activity. Large numbers of globular clusters surround them. They make up roughly 10 to 15% of the Virgo supercluster. M87 has a supermassive black hole at its core. The black hole was photographed using data collected in 2017 by the Event Horizon Telescope, E.H.T. It was announced excitedly to the world in 2019. In March 2021, the E.H.T. collaboration revealed a polarized-based image of the black hole for the first time. It was a pretty exciting event. It was the first time that a black hole had been captured. It happened all thanks to the Event Horizon Telescope, which is many radio observatories or radio telescope facilities around the world, all working together to produce a highly sensitive and high-resolution telescope. Another array of telescopes in Chile is called the Atacama Large Millimeter Submillimeter Array, ALMA. They captured high-resolution images of the 51 significant galaxies in the Virgo cluster. That's part of how we know what we know. M87 and other galaxies don't appear to be doing a lot to the naked eye. In fact, in a typical human lifetime, they barely move at all. Yet they are made up of gas, dust, and other objects that move through space at high speeds. They move when affected by the gravity of other galaxies, or dark matter, a mysterious entity that is 5 times more common than ordinary matter. Many galaxies, including our own, are believed to have a halo of dark matter surrounding them. The dark matter can pull more significantly on the smaller galaxies outside the clusters. As the galaxy gets dragged around through space, the star wrecker may come across. Giant clouds of intergalactic plasma, a form of electric gas, can behave like an atmosphere and drain the gas inside the galaxy. It sweeps out the gas inside the galaxy, stripping it of what it needs to make stars. It's hard to grasp the scale of this sort of activity, but that's what scientists now believe has been occurring to some galaxies or the nebulae without stars, as Charles Messier saw it. Now, let's park our space cruiser here and watch this thing in action. What we've been calling star wrecking is known as gas stripping. It's one of the most spectacular and violent external events in space. A scientist from the National Research Council of Canada said that galaxies are moving so fast through hot plasma in the cluster that a vast quantity of cold molecular gas is stripped from the galaxy. It's as though the gas is being swept away by a giant cosmic industrial blower. It's not the sort of clean-out we want to happen in our galaxy. You observe it in action. You're impressed, but equally respectful of its great power. The gas stripping, also known as ram pressure stripping, travels through many galaxies and removes a star-forming gas. The process is very efficient. The gas is behaving differently from the clouds in our galaxy. They aren't forming as many stars as they are in ours. A 21st century study found that the same process happens in smaller groups of only a few galaxies, with much less dark matter. The study looked at a staggering 10,567 satellite galaxies. These are galaxies that exist beyond the enormous galaxy clusters. Most galaxies in the universe exist in between 2 and 100 galaxies. They were able to study such a large number by using stacking. It makes it possible to learn about a collection of faint objects by combining all the information from the objects and making an average characteristic. They ultimately determined that gas stripping, or star wrecking, is potentially the main way that galaxies, predominantly star formation, are shut down by their surroundings. Pretty unfortunate to have such a nasty neighbor. So, now that your curiosity has been satisfied, it's best to leave this plasma cloud and get on with your journey to Outpost 52. You're going to be late now and could be in a whole lot of trouble. While the cruiser turns around, we'll head back to Earth. And back in time, back to 1744, to that night in rural France, where a teenager stood outside, marveling at the night sky and the spectacular vista of the six-tailed comet. And from that moment, was inspired to begin a lifelong quest based on a single question. Perhaps the ultimate of all. What's out there? Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface. So this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out. It just keeps it and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. but it's less transparent to lose long wavelength radiations that the warm, heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an OORT comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
Oh, fasten your seatbelts. We're setting course for the most bizarre places in our universe, and you'll see the most mysterious phenomena few people have ever seen before. Recently, astronomers have discovered that the supermassive black hole at the center of our home Milky Way galaxy might be leaking. Why is it a significant change? Because it might mean that this black hole, called Sagittarius A star, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active. And the leakage, recorded by scientists, may be the hole hiccuping while swallowing clouds of gas. Hey, I've been known to do that from time to time. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often occurs around other active black holes surrounded by the material drawn to them by their immense gravitational pull. Some of this material gets pulled into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches small jets of matter. Fermi bubbles might be the result of the belches that occurred around 2 to 4 million years ago. But recently, scientists have found another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now, let's visit some other breathtaking places in our universe. But be careful, some of them are extremely dangerous. Like this rotating neutron star called the Black Widow pulsar. Just like its spider namesake, it's munching on its partner, a lightweight brown dwarf star. The more material this pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. How about visiting a planet where it rains glass? Nah, I'd rather not. You see, this bright blue exoplanet looks peaceful and slightly familiar. Don't you think it slightly resembles Earth? But this pretty appearance hides the planet's terrifying nature. The winds blow at 5,400 miles per hour on its surface. That's 7 times the speed of sound. But that's not the worst. It rains glass sideways in this scorching hot alien world. Solar tsunamis are a solar phenomenon dubbed Terminator events. These tsunamis take place at the sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen every decade or so. Now look at this space body. Its nickname is Electric Hyperion. This Saturn's moon is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity, and it's flowing out into space. Look at this, a rogue planet with auroras. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras in the planet's atmosphere. Be sure to stay away from black holes. Do I really need to warn you? Yep, they're some of the most perilous objects in the universe. But how about mini black holes? Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. Ooh, I'll bet you like our next stop, a burning ice planet. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. That might be the reason the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, which remains solid despite blistering temperatures. Now, if you love jewelry, this next world is for you, a diamond planet. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. This in turn might mean that at least some part of the planet is diamond. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this one yet. Planets orbit stars, and moons orbit planets. But then, why can't there be moons, also known as submoons, moonettes, and moons? It actually sounds like one of those flowery Hawaiian dresses, moo-moos. But alas, no. Researchers claim that moons could exist, but the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Now, I'll take you to the living fossil galaxy. DG-SAT-1 is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, this galaxy is a real living fossil. Now, you won't be able to see the next space phenomenon, all because people can't see infrared light. And the phenomenon I'm talking about is an infrared stream from space. Ooh. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star, but this theory hasn't been proven yet. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Let's visit our star, but we need to be careful not to come too close, because the Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. Now, this space object is also worth visiting. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Ring-a-ding-ding.